Hi, Tom English again, and I wanted to continue a little bit with the trig functions and some practical problems. In fact, one of the things I want to, I guess, guarantee, the reason I am going to address these three, these are the types of problems you're going to have. I guarantee you, if not on your weekly test or chapter test, you're going to face them on the SAT, or sometime you're going to get these very same kinds of problems. The first example up here, I say, for instance, there's an individual looking at a flagpole. The question is, he's 40 feet from the flagpole. His angle of elevation in this case is 60 degrees. And the question is, how tall is the flagpole? If we look at this, obviously we form a right triangle with the ground and the flagpole. And if we look at the sides that we're looking for or know, we can see that we've got the side opposite is the height of the flagpole. That's what we need. We know we're 40 feet away from it, and we know the angle is 60 degrees. If we're looking at this angle, the side we don't know is the opposite. The side we do know is the adjacent. What trig function uses that, those two sides, opposite, adjacent? Hopefully you would say tangent. And so we would write this as the tangent of 60 degrees is equal to what? Opposite over the adjacent. In this case, 40. Now, we solved that for A. I'm not going to get into that, you can do that, but one of the things I want to warn you about, and it's amazing how many kids miss this, but you have to recognize this is at eye level. So if that individual is looking at up at the top of the flagpole, we have to take into account the height of the individual and add that, because our triangle is at his eye level, isn't it? So therefore, whatever we get for A, that's the flagpole, the height of the flagpole minus the length of the individual looking at it. So just for sake here, let's say he happens to be 5 feet tall. Then what we're going to have to do is we're going to have to add 5 to the height that we found from our trig exercise. And that's the kind of thing that maybe it's a little tricky, a little sneaky, but unfortunately so many kids miss it. They do the trigonometry fine, they just forget to add the extra 5 feet. Another typical problem is the ladder against a building. There's a fire, the firemen come up, they've got a 40-foot building, and they know they need to lean the ladder at a 50 degree in order to have stability. The question is, how far away from the building is that? And in this case, again, we're looking at, if this is the angle, the side opposite, and the side that's missing here would be the adjacent, wouldn't it? Again, what function uses the opposite and the adjacent? Again, it's the tangent function. So in this case, we'd say what? The tangent of 50 degrees is equal to opposite, which would be 40, over the adjacent, which is B. And again, I don't need to solve that for you, you know how to do it. But again, typical problem, ladder against the building, flagpole. Another one that's famous in that it's just used a lot is an airplane coming in. It sees the airport at a distance, and the question is, how far away from the airport is it? Well, we have to know, in this case we're saying they're flying at 6,500 feet, and the angle of depression, in other words, the pilot looking down from the plane, the angle that he sees the airport out there is at 30 degrees. The question is, how far is he from the airport? Well, the angle of depression is 30 degrees. That's outside the triangle, isn't it? But it's always measured from the horizontal. So one of the things we could do is say, well, the complement to that, since this forms the horizontal with the vertical forms a right angle, would be 60 degrees, wouldn't it? So now we can look at this triangle and say, okay, if I've got the angle of 60 degrees, the side opposite is what we're looking for, right? So the side opposite and the side that is adjacent is what we know. Okay, what is that? Well, that's the tangent again. And it's a tangent of what? 60 degrees. Okay, now you're dealing with some big numbers here. Typically, this might be 1.3 miles and finding it in miles, but you might have to convert what you get to miles. It depends how they ask you for that, but make sure you understand the difference between angle of elevation, angle of depression, and in this case we use the angle of depression to find the angle within the triangle, and then use our tangent function to solve for the distance. So hopefully you'll recognize those problems when you get to them. I guarantee you'll have them. Again, if not on a chapter test or semester exam, you're going to have them on your SATs and so forth. In fact, what I'd really like is that when you have a test and you get one of those problems, hopefully you'll think about it and say, oh, yeah, English mentioned that in his video. And every time you recognize that, please send me $1, because if everybody's watching this sends in the dollars, I'll be a rich man. Thank you much.